Good day, good morning. Thank you all for logging in. We're here to have a presentation on a very interesting subject from Dan Mendoza, who's with the Vertex Industrial Communications Group. Dan has been an instrumentation in technology for 7 years now. And he works with manufacturers all over the United States to support critical process equipment specializing in IIoT and AI. The webinar today is going to focus on AI-enhanced wireless condition monitoring. This is a very important subject and one that is gaining increasing traction. AI is redefining the approach to vibration-based condition monitoring by enabling earlier and more accurate detection of anomalies. Traditional monitoring approaches rely on manual interpretation and fixed thresholds, and often these have problems and fail to capture subtle or evolving false signatures in dynamic operating environments. AI-enhanced platforms address these limitations directly. They apply models that learn baseline behavior, identify deviations in real time, and automatically classify emerging fault conditions. By combining the wireless sensing technology that Daniel's going to talk about, along with edge analytics, AI provides a continuous, scalable monitoring platform with actionable insights that reduce false alarms and support predictive maintenance strategies. Now, as Daniel's going to start his presentation here shortly, but what I would encourage everyone to do is use the Q&A section at the top bar. If you want to submit any questions during Daniel's presentation, we will also reserve time after the webinar to engage in conversations and address any lingering questions at that time. So with that, Daniel, thank you for honoring us with your presence, and I'm going to hand it off to you to take care of the presentation.
Perfect. Thank you, Chuck. As Chuck introduced, my name is Daniel Mendoza. I am with the Vertex Group, specifically the Vertex Industrial Communications team. Today, I'm going to be going over the presentation, Downtime Prevention with Wireless Monitoring for Rotating Equipment. I'm not only going to touch on that specific point, but I'm also going to go into all the concepts and all the fundamentals that go into creating a full-scale solution. I will reserve some time at the end for questions, but then also I'll stop about halfway through to address any current questions. That way, any questions that come up during the first half of the presentation, they can get addressed right away. So about halfway through, I will stop. As I mentioned, my name is Daniel. I'm part of the Vertex Group. The Vertex Group is a conglomerate of manufacturers rep firms all across the United States. We have over 160 team members, cover 40 states, and have 9 operational companies. Within those companies, we're able to offer sales support at a local level, but also have the resources of a much larger corporation where we're able to compile our resources to support our sales teams. Some of the companies you might recognize here, depending on where you are located in the United States. We have Advanced Process, Alliance, FLW, Jasper, Gilson, and then a handful of other manufacturers rep firms as well. Vertex Industrial Comms, the team that I am a part of, specializes in a few different areas. My specialty is remote monitoring and sensor to cloud solutions. So this is everything from taking a sensor that's located out remotely in the field that you don't have any data on, and how do we get that information back and have usable data on it? And then everything with built-in sensor to cloud with AI protocols as well. But Vertex Industrial Communications does a handful of things within a couple different industries, such as everything from sensor to cloud all the way to custom field engineering services where we're building out a full-scale network. Today, specifically, we're going to be talking about not only one device, but we're going to be going over all the concepts when it comes to deploying a vibration analysis system. But it's important that we talk about multiple parameters because vibration analysis is not strictly vibration. There's also some other parameters as well, such as ultrasound and surface temperature measurement that we can all put together to create one full data point within a single pane of glass. So when we talk about rotating equipment health, this is everything from a pump to a motor to a conveyor belt, or anything that we're monitoring that we want to be able to take a vibration and ultrasound measurement on to be able to tell us the data point and the health of that equipment. Everything to internal leak detection, that whenever utilizing an ultrasound sensor, you could be able to tell if a valve is fully open or fully closed and if you have any leaks coming through that valve. And then all the way through steam trap as well, where we're utilizing an ultrasound sensor to be able to listen if any steam leaks are happening in that steam trap. So now let's go into the concept and how everything works together to create a full-scale solution. I mentioned it in the previous slide, but whenever we're looking at machine health monitoring and true predictive maintenance, we look at three parameters: ultrasound, vibration, and surface temperature. We look at these three parameters because it all tells us something different, and it tells us where we are at in the stage of that equipment failing. Ultrasound is the precursor. We listen before we feel. If you hear something happening, you're going to hear something happen before it ever gets to the point where it's going to shake or rattle. I have a nice case study towards the later half of the presentation that I'll dive into that more specifically, but I want to lay the foundation for the timeline of catastrophic failure. You'll hear something before it starts to vibrate. I like to use the example, if I throw a grain of sand into a bearing, that's not something that's going to cause any vibration change, but I will hear it on the ultrasound. And sometimes problems can start that small. Then once we move to the vibration state, we're actually at the point where something is starting to shake or rattle. You're at the point where something is happening. Something's already happened. Now you need to take action to maintain what has happened and fix the problem. And then if you get to the point where you're having high surface temperature sensing, to the point where you have extreme temperatures on some of your critical assets, you're getting very, very close to the point where you're at catastrophic failure, and maintenance should have already been taken care of. Talking about wireless connectivity, I'm going to talk specifically today about LoRaWAN because it's one that we recommend, but there's a lot of wireless connection options in order to get these sensors back to, get all these sensors communicating back to your home base or your main platform. And we use LoRaWAN because it's low range and low power. Anything that we're deploying under the industrial IoT network requires low power, so that way you don't have to maintain the thing you're using to maintain your current assets. AI-driven diagnostics. It's important whenever you're speccing out a solution to consider AI as an option for you. If we're used to process control, we're used to control rooms where we're analyzing all of our process instrumentation, and we're not utilizing artificial intelligence to be able to tell us that something is happening. When it comes to industrial IoT or the industrial Internet of Things, we want to utilize these tools because this is not something that we're sitting in a control room monitoring. Typically, we have 500, 800 pumps, motors, drives, conveyors, all at a plant that we want to be able to monitor, and it would be almost impossible for us to sit in front of a screen all day to monitor it. So how do we monitor all this equipment without being physically present at all times? We deploy an AI agent. AI in an application like this utilizes a baseline. So what we would do here is we would put a device on a motor or a pump, and then we would run that device until we have enough data points to turn on our artificial intelligence. From there, artificial intelligence has set a baseline for how the normal operating standards are for this pump or this motor. And then we would utilize AI to look for deviations outside of that baseline and look for frequency changes. So whether that's a frequency change on the ultrasound or a frequency change on the vibration, or if we have accelerated temperature rises, that's something that AI would be able to alert us on. And then we can have a person go in and take a look and understand where that alarm was coming from. Cloud-based visualization. This is how we view our data and how we access our data. Cloud is a scary topic for depending on the person and the market that you're talking to. So that's why it's important to look at how your data is going to be visualized and understand, do I need a cloud-based solution or do I need an on-premise solution that can only be accessed on my network? These are things you need to consider whenever you're speccing out a solution for your plant. And then ease of deployment. Anything that I'm going to deploy out there to help me is something that I want it to be done easily. Is my sensor going to be hard to install? Is it going to require a lot of hardware to get up and running? Does it require a lot of maintenance? Whenever you're deploying a solution, it has to be easily scalable so that way you can connect all of your sensors without having to frequently maintain those sensors or without having to go to links to install them. And then what are my target assets? Where do I start? How do I put these on? Where should I get started when deploying some of these sensors? That would be either on your motor, your pump, your compressor, your conveyor, anything that's going to be rotating, any valve that you have that you want to be able to make sure it's fully open or fully closed, any steam traps that you have. Those are going to be target applications that you'd look for. The more critical the asset is where you would get started first. One thing I want to make sure we address is that industrial IoT, and as I mentioned, IoT stands for Internet of Things. Industrial IoT stands for the Industrial Internet of Things. In terms of Internet of Things, this is anything that is connected to the internet. If you're at your home right now, this is going to be your Ring doorbell camera, your smart thermostat, your floodlights that have a camera on it. This is anything that you're going to be able to connect to the internet and access that data. When we're talking about industrial, this means anything that's rated for industrial environments on my plant or on my site. But it's important to note that industrial IoT is not the same thing as process control. When I think of process control, this is any flow meter, this is any pH sensor, this is something I'm deploying, and then I'm making process changes based on the variables that I'm getting. Typically, these are all real-time diagnostics. This is something I place something in, and I want to be able to know. For example, if I put a pH sensor in my application, I want to be able to know the pH value at every given second of my process, because I'm controlling my process and I'm dosing based on that measurement. Industrial IoT is used to be able to give you more data on applications that you might not be measuring on. For instance, if I have a pump that's controlling my flow, and I'm not only, if my flow goes down, I need to know it, but I also want to know the health of that pump itself. It's not process driven, but it's giving me insight into things that control my process. And that's where we deploy IoT. Typically, these are sensors that are going to be battery operated and wirelessly connected, which means I'm not going to be sending out a signal every second. Typically, these are signals that are going to be sent every 5 minutes, every 15 minutes, every 30 minutes, 60 minutes, because these are battery operated. If we ran the sensor every single second, you'd be doing more maintenance than you're getting diagnostics from. So this is something that I'm deploying, and I'm going to be able to grab a snapshot of my health every X amount of time frame. Whenever we're doing this, we go from firefighting mode to investigation mode. I talked about Vertex Industrial Communications. I work with all industries all over, whether that's pharmaceutical, water, wastewater, chemical, pulp and paper. Majority of the conversations that I have are on the grounds of firefighting mode. Maybe they have some sort of vibration sensor on there, but as I mentioned before, vibration tells me that something's already happened. So if I know that something's already happened, now I need to go investigate what's causing those frequency changes. Or if you don't have anything on there, you know that a pump or motor has gone down, and now you need to go investigate why. It puts you in a fight or flight response. A pump has gone down. This is a mission critical pump. It's important to my process. How much runtime am I going to lose off this pump going down? Okay, someone has to figure it out. That causes me to have a late reaction to something I could have already known was happening. I have limited visibility on the health of that critical asset. It's mission critical to my process, but I don't have any visibility or data on what's going on inside of it. Now I have an emergency investigation. This is the middle of the night. My pump has failed. This is something that's supposed to run 24/7. It's fire drill. Let me go out there and take care of it. And then also, you don't know what's causing it. All you know is that a pump has failed and you need to go fix it, but you have no idea what's actually caused that failure. Is it a lubrication issue? Is it a bent shaft? What's happening? You don't know. You're just in a firefighting mode where you have to put out that fire. And then you lose time in the field trying to diagnose something that's in the field, or you have to pull something out and then you lose process time. So whenever we deploy smart sensors in industrial IoT, the idea is to go from firefighting mode to now really I'm just investigating data that I already know. I have early data diagnostics because I'm taking an ultrasound measurement. I heard something happen before it ever started to shake or rattle, and I know what's going on inside that pump. I know the health status of that pump. I can use the trend analysis tools. I can use the data analysis tools to be able to give me a full picture of what's going on. You can learn machine behavior. How does my machine operate at any given time? And then you have diagnostics to support any upgrades that you want to do in the future. How do we go from collecting that data to actually deploying an AI tool to tell us? Well, first you actually need to deploy the sensor. This is an example sensor, but the idea behind this is to give you some concepts of what you should look for whenever you're deploying a sensor technology. One, you want long battery life. You don't want something that's going to cause you more headaches and more maintenance than what you're putting on to maintain. So if I'm putting a sensor on a pump in order to be able to give me diagnostic and maintenance tools, I don't want to spend more time maintaining my sensor and changing batteries. So you need something that consumes low power. That's why I recommended LoRaWAN earlier. LoRaWAN uses really, really low power rates, so that way you can send signals and get as much data as possible without having to perform maintenance. You want something that's 100% remote. I don't want to have to go walk, whether that's via the cloud or whether that's via an on-premise solution strictly connected to the network. I want something that gives me more data than I need. I want something that has so much data that I can go in here and make better decisions on whether who's looking at it, whether this is a maintenance tech who really just needs to worry about lubrication issues, or if this is a full-fledged vibration analysis engineer that needs to look at maintaining and controlling their process. It's important that you have all the data to support it. And then you want something that's environmentally friendly, something that's easy, something I don't have to be stuck in anything proprietary. This sensor, for example, uses 4 AA batteries, something that's very easy for you to pick up and change. There's no waiting. You can go out to any local store and grab some batteries. But now that I've collected that data, how am I going to process that data? Is this something that I'm going to spend time looking at on my cloud or looking at on my software platform and spending time analyzing this data? Or am I going to use an AI-driven tool to be able to give me diagnostics and tell me what exactly is happening? When you deploy artificial intelligence, as I mentioned before, you establish a baseline and then look for deviations outside of that baseline. Every frequency looks different. When you see changes in your frequency, it's able to you're able to deploy some symptoms and root cause analysis to be able to tell you what's happening. In this example, we had ultrasonic pulses and ultrasonic level increases, which possible root causes for a maintenance tech would be early stage of rolling element bearing wear. So they know exactly what they're doing when they go out there. This is the first thing I'm going to check when I go out there. How do I use the data that I'm getting to make better, smarter maintenance decisions? How do we set a foundation? How do I get that information? How does that information travel from me just deploying a sensor to making a better maintenance decision? Well, let's take a look at it. Sensors using wireless technology, there's hundreds and thousands of sensors out there that you can deploy using wireless technology, whether that's a vibration, acoustic, a temperature, a pressure, a level switch. All of those can either have built-in wireless connectivity, or they have a tool that you can connect to it in order to get that data to move. Whenever you're deploying a sensor, you'll deploy a sensor on an asset. That sensor will not only collect the data, but it will do edge processing. So when we collect a vibration sensor, when using a vibration sensor, for example, we're taking a lot of measurements all at once. And that raw data might not be as valuable without that still conditioning and that signal processing. So from that sensor, it will have edge processing. Edge means I'm out on the edge of my process. I'm doing it at the sensor itself. That sensor will process that data, and then that sensor will communicate typically to some sort of gateway. A gateway, you can imagine, is like a wireless router inside of your house. It's a little box with an antenna that's collecting data. That sensor will communicate to a gateway, and then that gateway will either communicate to a platform via an Ethernet connection or some sort of cellular connection. That's typically how the data will travel all the way back to a cloud solution, where now you're at your platform where you're storing your data, you're analyzing your data, and then from that data, you can make better maintenance decisions because you know exactly what's going on. Chuck, I'll stop here. Are there any questions in the Q&A?
Yeah, there's one from Dylan. He was curious if these sensors had Class 1 Div 1 approvals.
Every manufacturer will have something different. The sensor that I showed earlier was Class 1 Div 2 or general purpose. But there are Class 1 Div 1 vibration sensors out there. Absolutely.
Okay, and I did have a series of questions that were sent to me by people that are planning on watching this. One that came in that you haven't yet addressed, you may be, this might be a precursor. It's actually twofold. His question was, what are your recommendations if we want to monitor pumps that don't run 24/7, but we still want data on? And then he also followed that up with, his company doesn't allow anything to be put on the cloud. What options are available?
Sure. So to address the first question, you would look for a sensor that has what I call wake up technology. So wake up technology means that I'm able to wake up based on a certain parameter. A lot of battery wireless operated sensors that you deploy out there are on and off. Either I'm on and I'm collecting data, or I'm off. Without some sort of wake up technology, you won't really be able to control that. So for an example where I'm taking a measurement every 3 to 4 days and I don't need to run my sensor all the time, I would deploy a sensor that's able to recognize that that pump has turned on, and then you can start collecting data. Because as I mentioned before, if you're spending the majority of your time maintaining the sensor that you put on to maintain the pump, you're not getting as much value out of it. So I would look for something that has some sort of wake up technology in order to be able to turn on and recognize that your pump has turned on. And then the second question, in terms of cloud-based visualization, that's a question that I get asked almost every single day. And I understand that different industries are going to have different protocols behind that. But majority of the time, any manufacturer that you go with is not going to only have some sort of cloud-based visualization, but they'll have some sort of on-premise solution. So what that looks like is taking what would be in the cloud, that software, and they would run it on a virtual machine hosted on your own private network. And so that way, any data that's going to be accessed from those sensors would all be on your network, where IT and OT have full control over any data that's being accessed.
All right, thank you. Carry on.
So as we're deploying sensors, it's important to be able to have a measurable impact, because everyone's going to ask, if I'm going to deploy a sensor, what is my ROI going to be on this sensor? No one wants to deploy something and spend money where they're not able to measure how they're going to earn that money back. So when I deploy, and on the left side, we're looking at where I'm going to deploy these sensors, whether that's a ventilator, air boosters, pressure pumps, hydraulic pumps. If I deploy my sensor, how can I measure my ROI? And so now let's move over to the right side. How much does it cost you to have a pump go down for an hour? If you can reduce a pump going down for an hour or 2 hours or a day, how much are you able to increase your process yield from? That's going to be your measurable impact when it comes to fewer failures. That results in savings, cost savings. If I'm spending money maintaining a pump, for example, something has happened later on, now I'm getting vibration and rattling issues, and I need to spend more money to maintain that pump, whether it would have been caught earlier in the stage with an ultrasound sensor. How much does that save me financially? If I'm looking at getting alerts before anything ever turns into a work order, how much does that save me financially, where I don't have maintenance techs running around trying to maintain pumps that I should have health diagnostics on? And then your overall maintenance cost. How much am I paying these technicians to go out there and maintain these pumps? How much am I spending rebuilding a full entire pump when I could have caught something much simpler days or even a week before? And that's where we move from the standpoint of, I'm getting preventative maintenance where I have a lubrication. Let's say I have a lubrication schedule where I'm lubricating 1 time a week. I deploy an ultrasound and vibration sensor. I understand now that I'm not lubricating enough. I need to lubricate twice a week. Yes, you're going to be spending more to maintain, but how much savings are you going to have knowing that your pump is working better overall because you're lubricating and making smarter decisions based on the preventative maintenance schedule that you found through data, opposed to having a preventative maintenance schedule that was set in place by somebody 25 years ago, and that's just the way that you've always done it. So what's a use case example? I've removed all customer data from this, but we have a application here where a customer wanted to deploy detection and preventative condition monitoring maintenance on 70% of critical assets. So this is your pumps that you cannot afford to go down. These are your VFDs, your motors. This is stuff that I cannot afford for this to go down even for an hour, even for a day. I need these up and running. These are running 24/7. So we deployed a wireless condition monitoring solution, like what I've discussed previously, on 70% of the assets. And the key thing here is down here, but I'll touch on these. What does it mean? So majority of the assets would have gone down or would have had some sort of failure without a early detection. As I mentioned before, ultrasound tells you that something's going to happen before it ever gets to that failure point, or before it ever starts to shake or rattle that's going to cause more damage. So major breakdowns, we were able to avoid 30% of major breakdowns on those 30% monitored assets. And then 40% of the assets, we were able to detect minor incidents that would have caused issues. Like I talked about earlier, proper lubrication schedules is just an example. But the idea is, I want data without a false positive. I wanted to know that something's happening before it happens, where I'd have to go out there and waste my time trying to maintain or understand what's going on. And it shifts your framework from reacting to a failure to preventing that failure from ever happening. I'm going to touch on LoRaWAN here. LoRaWAN is just one way to get your data from a sensor back to a cloud or an on-premise solution. It's one of the many wireless connection methods. It's the one I prefer because it's the lowest power and the longest range. If I'm going to deploy something, whether that's in my house or in my plant, I want something that's going to be the easiest to deploy. I'm going to be able to use the most amount of sensors at the longest range, so I don't have to install extra hardware. I want something that's going to be the most cost efficient, best solution. And that's why I recommend LoRaWAN for a sensor that's using these parameters. I'm going to just read off the LoRaWAN. If you're unfamiliar with LoRaWAN, I'm going to read off the definition of LoRaWAN to kind of paint the picture, and then I'll kind of talk about the below squares here. So LoRaWAN is a low power, means using low power to be able to communicate from the sensor to the gateway. Wide area network, which means I'm covering a long area. I'm not doing a small run where I'm connecting from one sensor to one gateway that's in close proximity. Designed to wirelessly connect battery operated devices to the internet. How do I go from sensor collection, data collection, to getting that data back on the internet so that way I can access it remotely? Long range. If I'm deploying a sensor, and if you can see my mouse, I want something that I'm able to deploy a sensor here. I'm able to deploy a sensor here. I'm able to deploy a sensor here without having to install a bunch of gateways. I want a gateway maybe here in the middle, or maybe here on the left side, here on the right side, and I want all of these sensors to communicate to the one that's in closest proximity and that has the highest signal strength. That's why I like LoRaWAN. A typical plant that might require, if you're using some sort of wireless HART or mesh network where you have to deploy maybe 15 to 20 gateways, we can accomplish the same measurements with 3 or 4 utilizing LoRaWAN. I want something that's low power. Low power meaning how much battery power do I have to use to get all of that data back to my gateway? The faster that you're communicating, the more power that you're going to use. The more signal strength it requires to get my sensor data to the gateway, the more power I'm going to use. If I'm deploying something on an asset, I want to use the least amount of power possible because I want to be able to, these are all battery devices. So I want to deploy my sensor on my asset, and then I don't want to have to worry about that battery life for several years. I want to take full advantage of the perks of using a battery operated device. With LoRaWAN, it uses really low power in order to communicate, which is why I recommend it. Scalability. I talked earlier about 15 to 20 gateways on a mesh network opposed to something like a LoRaWAN network. That makes me being able to scale my solution much easier. I talked earlier about whenever establishing the framework, I'm not only solving today's problem, I'm solving tomorrow's problem. If I don't think about scalability before I deploy a solution, I'm not thinking about tomorrow's problem, and I'm not thinking about how I can better scale this. Today, I'm going to be monitoring air quality via LoRaWAN, but tomorrow I want to be able to monitor valve position on all my manual valves. If you have to interlink different networks, you're going to be causing more maintenance on yourself because you didn't think about how I can scale this in the future earlier. And then integration. Everybody, typically most plants that I talk to already have some sort of SCADA system or some sort of reliability software. Can I integrate the current data system that I have can I integrate the current data system, the data that I want to collect into the current existing system that I have? With LoRaWAN, you can do that. And then mix in different devices and vendors. I don't want to be locked into a specific vendor. For instance, a vendor that is selling valve positioning LoRaWAN sensors might not sell gas detection or air quality monitoring. With LoRaWAN, it doesn't matter who the vendor of the sensor is. As long as it's configured correctly, I can gather all of my LoRaWAN devices and get all that visualized utilizing LoRaWAN and be able to connect it. So it's important that you select a system that is going to work for every single one of your needs and not just one specific one. And then cost efficient, lowest cost of ownership, lowest cost to install. With LoRaWAN, where we're covering where we're utilizing 3 or 4 gateways to monitor a whole plant, we're able to also deploy thousands of sensors on that gateway. Because it's using really low power and really low frequencies, we can have thousands of sensors connected to a single gateway without issue. Star topology versus a mesh topology. This is your actual network and how your data travels from the sensor to your gateway. So LoRaWAN utilizes a star topology where I have a gateway in the middle and and all my sensors are communicating directly with that gateway. As you can see here, these are my sensors. This is my gateway hub. From my hub, that's where my data gets sent to my cloud or my software solution. So all your sensors are collecting data and communicating. Utilizing this topology, we're able to use a lot of sensors with very limited gateways. Because we're doing a measurement we're not doing real-time process control. This is the best topology for predictive maintenance. I don't need something that's going to be able to take a signal and a measurement every second and communicate that back. And I have a bunch of interweaving going on here. I'm taking a measurement every 5 minutes, every 10 minutes, and I'm sending that back. And that's perfect for what I'm trying to accomplish here. Versus a mesh topology. Now, I'm not saying a mesh topology is bad, but I'm saying that everything has its use case. With mesh, how it works is that we have a bunch of different sensors and we have different paths in order to get that data back to where I want it to go. So here, my data can travel from this point to this point, or if this point fails, it will travel this way and this way. It has its place when it comes to process control, but for something where I'm using preventative maintenance with sensors here, where I'm just gathering data, I'm not necessarily controlling a process on, I don't need all this redundancy, because with that redundancy, you're going to have shorter ranges that you're going to have higher cost to operate, because I'm going to need 18 to 20 gateways in order to be able to communicate, because you're creating a redundant network here. If my point fails here, I want it to be able to go here. That's going to cause you're going to need another gateway to repeat that signal. Everything has its place whenever you're considering a solution. I recommend LoRaWAN when I'm using a battery operated devices because I want the lowest possible consumption, the longest range I can get with the least amount of hardware that I need to install to get it up and running. Here's a case study. I talked earlier that I would go over a case study on why ultrasound is so important when it comes to measuring health monitoring of your critical assets. This is a case study from a company, Equinor, that has a drilling platform out in the North Sea. They wanted to be able to install some wireless sensors on their top drive to be able to monitor the health of it. And so I'm going to skip this one because this is where the real meat is. They had an ultrasound alarm go on. And if you look at the other graphs, you'll see that the ultrasound alarm happened. And what I mentioned earlier, ultrasound tells us that something's happening before it ever gets to the point where I have to do true maintenance on it. Okay, the idea is to stop anything before it ever gets to the point where I'm shaking and rattling and causing damage to my asset. They had an ultrasound alert go on, vibration remained the same, and temperature remained the same. Typically, this customer, whenever they get an ultrasound alarm, they lubricate and everything goes back to normal. So they inspected the top drive, lubricated the top drive, put it back running again. They noticed that the ultrasound alarm was still on. So at the next planned drilling stop, they stopped, opened up the top drive, and they noticed that they had a broken spring leading to metal on metal contact. If left unchecked and relying strictly on a vibration measurement, this cost to repair would have gone from simply a metal spring that I need to replace to way a much more higher maintenance cost to get this up and running again. So this specific customer, I understand this is a drilling platform, everything costs a lot of money. This specific customer considered the savings between 800,000 and $1 million. This is on a top drive on a drilling rig. When we think about critical asset points on a VFD or on a motor or something like that, the cost is going to be different, but the idea is still the same. If I can prevent even higher maintenance failures, I'm going to be saving money in the long run with my ROI. You can look at this. This is a little bit of a better analysis if you want to get an idea on exactly how it was used. So this sensor was placed here to be able to monitor the torque frame. It got out of position and leading to metal on metal friction, and that's what actually caused the issue. Could have had a much higher maintenance cost if not addressed. Last couple slides here, and I just want to continue to reiterate that whenever you're deploying a sensor for a problem like this, it is so important to think larger scale. Whenever it comes to IoT, all of the considerations that I've talked about before in the previous slides, is it going to connect to my existing system? Can I use multiple sensors from multiple different vendors? If I deploy a network today, will that network still be available on a different sensor tomorrow? This is why I say going from a singular problem where I have a problem with this specific pump and I'm going to deploy a sensor that uses this connection method in order to solve it can be a risky mistake. Because if I deploy a sensor to solve one specific problem, especially an IoT sensor, is that going to be scalable for me in the future? If I solve the problem here with one sensor and one gateway, but now I want to be able to monitor multiple pumps and multiple motors, how much is that going to cost me now? So it could be a costly mistake if you're just trying to solve a singular problem. Why is that? What I talked about. Is this going to be easy for me to scale in the future? If I deploy a sensor today, can I easily scale another 100 sensors tomorrow on 100 different pumps? That's a decision that needs to be made before you ever deploy a solution. Data ownership. Am I going to have access to my data? Do I have to use a specific program? Do I have to use a specific vendor type for my connection? If I'm utilizing this wide area network, am I going to be locked out of specific sensors that I want to be able to monitor? I talked earlier about utilizing LoRaWAN. That's not something that's proprietary to my company or anything, but it's what I recommend because you can use multiple different sensors. You can use multiple sensors from multiple different vendors and utilize the same hardware in order to gather that data. Is my data going to be able to integrate with my existing systems? Am I going to have to use something proprietary, or can I take that data and get it into my existing reliability software or my SCADA system? These are all things that you need to think about before ever solving a singular problem, because IoT is giving you more data into measurements that you're not currently taking. And then lastly, I think this is my last slide. If I needed to get started and I'm thinking about solving a singular problem, what are the steps and what's the roadmap that I should take? Well, one, you need to start thinking about all the possible scenarios that you can deploy this sensor. If I'm going to go to the links to deploy a wide area network, like a wireless HART, a mesh system, a LoRaWAN system, what other areas can I deploy sensors on utilizing the same network? How can I deploy this the most cost efficiently? I need to get IT and OT involved. IT is always going to have a say, especially anytime the word cloud gets mentioned. IT is going to want to know about it. If you're a company that doesn't allow anything on the cloud, okay, what software considerations do I have in order to keep this on my own network? What technology am I going to choose? Am I going to be monitoring vibration? Am I going to be monitoring temperature? Am I going to be monitoring level, flow? Can all of these be integrated with the same network? And then we get to the point where now, okay, I've chosen a network, I've chosen where I want to go. Maybe you chose two networks so that way you can have redundancy. And now I can go to the point where I'm actually deploying. So that way I don't cause issues for me in the future where now I need to either change something, I need to take something out. And then how scalable am I going to be able to make this? So start with your potential, and then you can start isolating singular problems. Sorry, this is the last slide. So just to reiterate, in conclusion of my whole presentation, don't buy a singular sensor for one singular problem. Think about it on as a full scale solution that you're deploying. I'm deploying a full network, and how can I get as much value out of my network and out of my infrastructure that I'm deploying? Monitoring is just the first singular step. Now that I have my monitoring in place, what can I do with that data? What all analysis can I run on that data to make better decisions for all of my equipment tomorrow? And that's everything.
Well, thanks, Dan. Greatly appreciate it. Very informative. The key factor is saving money, return on that investment. That's key. Reducing downtimes and other things. So thank you very much. If anybody has any questions, feel free to open up your mics and ask. I do have a few. One is from Jeff. He asked, does this technology work on low RPM machines, such as filling machines at about BRPM? I think I'm reading that right, Jeff, with one main bearing that is very expensive, so usually not in stock anywhere.
How many? What was the RPM?
8 RPM.
Eight. I'm sorry. I did miss her. Thank you, Jeff, for chiming in.
It's going to be extremely difficult. Typically anything under like 150, 200 is going to be harder to get true accurate data on. I would say it's worth a shot and it's worth a try, but I wouldn't invest. I would try it before I ever invested in a full network. Something that low is going to be really hard.
And
Fair enough. Thank you.
Thanks, Jeff. And then going back to some of the questions that were submitted by people who are going to watch the recording, one of them, and we hear these terms bantied about quite a bit, he simply asked for your explanation and vision on the difference between predictive and preventive maintenance and how this type of equipment can assist those goals.
Sure. I'll start with preventative maintenance. Preventative maintenance is anything that's going to have a standard operating procedure on. If that's a pH probe, my preventative maintenance is calibrating that pH probe, cleaning that pH probe. I have some sort of schedule that I've established, and either that's a schedule established off data points, or that's a schedule established off of, well, this is the way that Joe told me to do it 20 years ago, and this is the way that we've always done it. Predictive maintenance is utilizing data and industrial IoT to better maintain those schedules. So this is everything in between those standard operating procedures. If my lubrication schedule, as I mentioned before, is every 2 weeks or every week, and I'm lubricating one time, utilizing predictive maintenance can tell me when exactly I need to lubricate, so I can better redefine my predictive or my preventative maintenance.
And then the other question, you might have already addressed this, but I want to make 100% sure because he did ask this, and he was questioning whether the data could be integrated into his existing software or SCADA. And I'm pretty sure you did answer that, but I'd maybe ask you to reinforce that.
Yeah, there's, depending on the vendor that you go with, majority are all going to have some sort of integration methods, whether that's in a couple different options in order to get it. There's a lot of different ways. Primarily, everybody's probably heard of an API or a REST API. That's traditional method, but there's also MQTT, there's WebSocket. There's a lot of different ways to get that data back to your SCADA system, depending on what your SCADA system needs. Every software or SCADA system is going to be a little bit different, and the different communication methods that they accept. So depending on that, that's the one that you would select. But yes,
All right.
it's available in an option.
Are there any other questions from the group out there? If so, feel free to open up your mics and ask. Daniel and I will stick around for a couple minutes here. The slide sets from this presentation, we will see that they are emailed to you. And also access to the recording will be made available. And I'll also post some information on the ISA Tampa LinkedIn site. So thank you very much for your attendance. And again, Daniel and I will stick around for a handful of minutes here in case anybody wants to chime in with questions. Have a great day, everyone.
Thank you.
Thank you.
Thank you.
So Daniel, I have a follow-up question on my other question.
Okay.
So the reason I asked that is because I work for Pepsi, by the way. So we use these filling machines all the time, right?
Yep.
And pharmaceutical would be a similar thing where you've got a rotating machine filling a bottle or whatever.
Yep.
Those things, like I said, generally run about 8, 9 RPMs at the most. And we have been trying to do this using vibration, and I got the same answer that you gave. So the company we're working with has been working on some sort of pilot. They're not doing it at my plant, and I haven't heard anything about it. But I guess what I'm picking your brain for, is there any other kind of technology outside of vibration, maybe ultrasonic or whatever, that could detect pending failures of a bearing that's like 8 feet in diameter?
8 feet in diameter?
Yeah, these are like $10,000 parts. Nobody stocks them. And when we do have one fail, we have to have the OEM go back to the drawing board and manufacture a new one.
So I'm gonna let me.
And if I'm putting you on the spot, I apologize.
No.
I was very interested in what you're showing here, especially that low WAN stuff.
Yeah.
That I'm going to follow up on.
So
because we use Bluetooth on ours.
So this sensor, and I try to keep everything vendor agnostic on a situation like this, but I'll just say this sensor itself is used on both rotating and non-rotating equipment. So non-rotating equipment, I would assume that we would be able to deploy this sensor on there and be able to get you some data diagnostic points. Would it be the same as putting it on something that rotates 250 to 700? Probably not, but it's not that expensive to trial. And we do pilots all the time where I can send you a sensor and trial it out and see if we can get some valuable data out of it. And I think it'd be worth it.
Yeah, let's follow up on that, Daniel.
Yeah.
Yeah, my email should be in here, but if not, I'm the president of the ISA, so I'm probably on your email chains that started this whole thing.
Okay. Are you which facility? Are you at the Orlando facility?
No, I'm at the Tampa plant.
The Tampa plant? Okay. I'll see if I'll get your email address from Chuck, and we can talk about sending something down to trial out and see if we can get some valuable data off of it. We do that all the time.
Cool. All right. I didn't want to monopolize the thing. Is there anybody else that has any questions?
Yeah. Hi, this is Ian Trucco. I work with Phoenix Contact. Do you know of any of these devices that are APL capable? Do you know APL?
I'm not familiar. What can you tell me a little bit?
It's like single pair Ethernet, but for like C1D2, so like power and data over Ethernet. But for a classified area, so devices that can live in explosion-proof areas, but can be powered and get data through Ethernet, like 2-pair Ethernet.
There are a couple vendor sensors that I know are class 1 div 1 or class 1 div 2, but actually communicating from the sensor itself or from the gateway via Ethernet.
I mean, the sensor has to from the sensor itself, so that's kind of the thing, is removing a lot of need for
battery operated
and getting power and data straight from the sensor.
I don't know of any vibration sensor that would be powered over Ethernet. I know you can. A lot of the ones that I work with are all going to be battery operated. So that's not only that sensor I just showed you, but other competitive sensors as well. Typically are going to be battery operated. Now, from the sensor itself, I mean, you're not going to have to power these. I mean,
Right.
depending on how often you're wanting to take a measurement. Typically, we can get 3 to 5 years out of battery life out of this. Whenever you're sending a signal every 5 to 30 minutes, you can get
Yeah.
5 minutes. You're going to get a year's worth of battery. If you send something every 30 minutes, you'll probably get 3 years of battery. So it's not going to be something that you're going to have to maintain a lot. So are you wanting something more real time where you're sending a signal out every second or every a couple signals a second?
Yeah, I guess that's kind of the need for it in other applications is
Yeah,
constant data stream.
yeah, you're probably going to want to go towards more something that's like a PCB or a Kistler or some sort of accelerometer where you actually but understand that because the hardware needs is going to be much more with something that's like battery operated. Like the one I just showed you was adhesive mounted. You stick the
Yeah.
adhesive off, you put it on there, and it communicates wirelessly. Now you're not getting something real time, but your hardware needs is much less. With like a
Right.
PCB or like a Dytrans or something like that, somebody that sells accelerometers that are used to get 20,000 signals a second, you're going to need not only the sensor, but you'll also need the signal conditioner. And I'm pretty sure they have somebody out there, PCB, Kistler, whoever you use to get that signal from. I'm sure that they have some sort of power over Ethernet option. I'd be surprised if they didn't. I don't sell those kind of accelerometers, but I know it's out there, and I'm sure they have something. So if you have like a one-off application where, hey, I can afford to have some extra hardware on this, and I just need power over Ethernet, I would say contact somebody like that, like a Kistler or PCB or Dytrans. They all make accelerometers for real time.
Okay. Thank you.
Yep.
Are there any other questions? Okay, well, we appreciate it. If something comes up afterwards, there's Daniel's contact information. Feel free to reach out to him. Again, we'll email the copy of the presentation to you and make the recording accessible. Again, Daniel, thank you very, very much. It was very informative. Really appreciate you taking time out of your day. And
thank you.
I wish you all a great day and a balance of your afternoon.
Thank y'all. Y'all have a wonderful day. Enjoy your evening and your weekend. Have a good one.
Yeah. And the ISA
Same to you.
Tampa
Thank you.
chapter. Thanks you. Take care, guys. Bye-bye.
Thank you. Take care.